Hi everyone, and welcome back to another Unit 9 video. We've only got a couple more to go to finish up this Unit 9 note packet. We're just going to get through Part 5 during this unit during distance learning. But again, today we're going to focus on Part 4 of the Unit 9 note packet. So today we're going to continue to build on everything that we've talked about in the past in Unit 9. We've been working really hard the last few days on finding surface area of prisms and of cylinders and of pyramids and in cones. And, surface area is one way to kind of classify and to kind of, analyze a three-dimensional object. Today, we're going to talk about volume, which is another way to do that. Surface area is a measurement of if we were to like unfold this three-dimensional object, how much space could it lay across, right? How much space are its walls taking up, the surfaces of this object? For volume, we are fully concerned about how much three-dimensional space does this thing just take up while it's just sitting there in space. That's what volume is all about. So just like surface area and regular area and all of that, volume requires a formula, and it requires you to look at different things on, these figures and find different components of the figures and use them to figure out the volume of those figures. And so let's just get right to it. That's enough talking. So just one more reminder, what volume is how much 3D space a figure takes up. And so for prisms and cylinders, which is what we're going to talk about today, tomorrow we'll talk about the pyramids and cones again, our volume will be big B, which we should be familiar with that. We call that the area of the base. And then we're going to times that by the height of the prism or cylinder. So again, big B, area of base, and then H is the height of the prism or cylinder. And so again, a lot of this, has similarities with the surface area component of this unit. We need to analyze the base, maybe draw the base. We need to figure out the dimensions of it. We need to know the formula for finding the area of just that base, because we need to get big B, which is the area of a base. And then finally, we need to times that number by the height of the prism. So let's go start. Let's do number one. So when I look at this rectangular prism, right? This is a rectangular prism. It's like a box. Because everything's a rectangle in a rectangular prism, anything can be considered our base. So for simplicity, I'm going to consider the bottom, our base, the very bottom side of this box. And so that's what I'm going to work with as I try to find big B. So I'm going to draw that base, right? There's the bottom rectangle. One side is 12, other side is 4. In a rectangle, we know, right, opposite sides are congruent. So we know if the bottom's 12, top is 12, right is 4, left is 4. Now, none of that is huge because we don't need to find perimeter now for volume. We just want area of base. So I'll call big B. Remember, area of a rectangle would just be little b times h, base times height. And so in this problem, that'll be 12 times 4. And so our big B in this problem, again, is going to be whatever 12 times 4 is, which is 48, right? And we can call that meters squared. So our big B is 48 meters squared. And then for volume, remember, we'll go back up here. It's just our big B times the height of the prism. And so now we can try to find volume. Now, real quick, let's talk about what the height is. Just like in the surface area examples from the last few days, your height is the distance of the wall that connects your two bases. And so remember, we have a bottom base, but a prism always has two bases. And so opposite of that would be the top. We would consider that a base 2. And so the height of the prism is how big is the wall that connects these two bases. And that's like this side right here. And so that would be 9. And so if we want to find the volume, that 9 is our h. And remember, we just found big B down here. And so our volume will be 48 times 9. And when we do 48 times 9, we get 432 meters. And this time it's to the third power. meters cubed or cubic meters. Volume has cubic units. So we are raising volume units to the third power. So let's just keep that in mind. All right, and that's the whole problem. So let's go do it on number 2. 2 is a cylinder. Just knowing that is important because we always need to know what our bases of our 3D objects are. And for a cylinder, we have a circle base, right? And so I'm going to draw the circle. You can tell by the dimension that this circle base has a radius of 4, so r equals 4. Just in case, we know that our diameter would then be 8. It's twice as big. But I don't think we'll actually need that today. The reason is, remember, once we get our base down, we want to find big B, area of that base, and then we need to times it by the height in order to get our volume. So big B, area of the base for a circle, is pi times radius squared. And so pi times 4 squared in this example. And we can throw pi times 4 squared into our calculator. Second pi, parentheses 4, and squared. And we will get 50.3 roughly. And so 50.3 is our big B. And then what's h? Now we need to know what our height is to be able to find the volume. Remember, height is the distance connecting our two bases. So that would definitely be 2.5 in this problem. And so our volume is then big B, which is 50.3, times h, which is 2.5. And let's multiply those together. I'll even go back to my calculator this time. So my 50.3, I'll just hit times, and I'll do 2.5, and we get 125.7 roughly, 125.7. And centimeters cubed, centimeters to the third power for volume. Awesome. Let's do one more. All right, so we got a sandwich here. We will consider this sandwich to be a triangular prism, right? We've got a triangle on top, so that's why it's called a triangular. That would be considered our base. We would assume the bottom of that, the other sandwich bread, would also be cut in a triangle. That would be the other base. And then this distance here would be the walls of our prism, right? And so that makes this a triangular prism. Since we already talked about the walls of our prism, we know that this 2 would be our h then. That's the height connecting our two bases. And then now we just need to find area of our base. Now remember, we called it a triangular prism. So a triangle, I'm going to draw it kind of like this, is our base. So I'll call this 4 and that 3. And one thing I'm going to assume in this problem is that that's a right angle. That is a right angle there. And that's awesome because remember, as we find, so we need to find area of our base. And area of a base for a triangle, little base times height divided by 2, right? And the issue with the base and the height in the triangle is that your base and your height always need to be perpendicular, meaning they need to be meeting at a 90-degree angle. Sometimes they are in triangles that we get, other times we have to go figure that out by drawing, imaginary lines from tips into bases and things like that. In this example, we don't need to do that because there's already the right angle. And so we can consider, I don't know, like 4 to be the base. We can consider the 3 to be the height. And so the area of this triangle would be 4 times 3 divided by 2. 4 times 3 is 12. 12 divided by 2 is 6. So 6 inches squared is big B here, big B. We already talked about h, which is 2 over there. That's the distance connecting the two bases. And so we are ready to find our volume. Volume is big B times h. So 6 times 2. And 6 times 2 is 12, right? 12. And units are inches to the third power, 12 cubic inches. All right, let's keep rolling. I think we had 2 more problems left. Here we go. Now we got to work backwards. So we have a cylinder again. Remember, a cylinder has a circle base, right? And so draw this base. and x is my radius. So x is what I want to solve for. This example says solve for x, right? And so I need to solve for x. So big B, right, is pi r squared. Big B is the area of our base, and our base is a circle. So the area of a circle is pi r squared, but we don't know r, right? R is just x, but I can put it in there. So pi times x squared, I guess. Now, if you come over here and look at this 12, right, that is the distance connecting our top and our bottom circles. So that's our big H in our volume formula. And so now we can use all this information to solve for that x. It just takes a little bit of algebra to do it. So remember, volume equals big B times height. Now, we know the volume. So I can plug 4,561 in for V. 4,561. And that's going to equal. And I know big B with an x in it, right? I can write big B as pi times x squared. Perfect. And then I just need to solve for that x. And lastly, I know h, right? H is just 12. So instead of h, I can write times parentheses 12. Now, let's clean this up a little bit. Let's combine like terms on this right side a little bit, and I'll change colors. Since everything's multiplying on this right side, let's combine 12 and pi into one thing. And so we're not going to touch the 4, 5, 6, 1 yet, but it's going to equal whatever 12 times pi is. 12 times pi equals 37.7. So this will equal 37.7 x squared. And then let's divide both sides by 37.7, right? Because then we can get x squared by itself, which will then allow us to get x by itself. Because the two 37.7s will cancel, and it'll just be x squared on the right. And let's see what 4561 divided by 37.7 is. 4561 divided by, and I'm just going to hit up twice. Oops, maybe once. Highlight that, hit enter, boom. So about 121 if we round up, about 121.0. And so then the last step is if we want to solve for x, which is our radius, right? Well, now we have x squared, so let's take the square root of it. And if I square root 121.0, or just that number we have on the calculator here, second, square root, hit up and enter on the 120, enter again, you'll see that it's basically 11.0, right? Basically 11.0. 11.0 meters is what x was, which is our radius, and that is the answer for the problem. All right, awesome. One more problem left. The volume of a rectangular prism is 720 inches cubed. So volume equals 720. If the dimensions of the base are 10 by 12, what is the height of the prism? So one side's 10, one side's 12. All right, so here we go. Remember, for volume, we want big B times H. Obviously, H is what we're looking for this time, so we want to figure out what big B is. So if I draw my base, part of it's 10, part of it's 12, and that's a rectangle. So remember, big B for a rectangle is just base times height. So that would be 10 times 12 in this example, which is 120. So I know big B. And so remember, if volume is big B times H, I can plug in big B. And I also know the volume that was given to me, so I can plug that in. And I just solve for H. So I get 720 equals, and again, big B is 120, so 120 times H. And I just have to divide both sides by 120. So divide by 120, divide by 120. And 720 divided by 120, I believe is 6. Yes. So 720 divided by 120 is 6. And our units are inches, and that's already our final answer. All right, everyone, we just did this whole part in one video. Can you believe it? We are running out of time, so I got to wrap it up. Go ahead and practice the Part 4 worksheet. If you have any questions, please reach out or come into the Google Hangouts. I would be glad to help you, but keep up the great work. You are doing an awesome job. Have a great day, everyone.